Hello and welcome back to this lesson or video number 6 of this Introduction to Trigonometry, or a helicopter overview of trigonometry. In the previous videos we learned how to, actually in the previous one, in number 5, how do we convert from radian to degrees, and how do we find out the angles within the special triangles, the two special triangles that have 30, 60, 120 and 150, because 120, 150, remember, reference angle, that's all you need to remember. There's no memorization here. So when you have 120, the reference is 60. When you have 150, the reference is 30 degrees. And when you have 135, the reference is 45 degrees. And you do the same thing with the third and fourth quadrant. And again, we said location, 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 location of the angle to find the reference angle by drawing from the tip of the vector that perpendicular to the x-axis. So at 240, we have that 60 degrees. And then we can compare that, because cosine and sine, we said the ratios, they're just comparison. You're comparing the vertical or the horizontal component of that vector, rotating vector, moving, that makes this whole to the actual vector or the total force, which makes the total animation of those segment lengths a frequency function that repeats the same cycle within the same interval of time. We talked about all that. And then we gave the examples of easy angles, the ones like with the 150, which is the 5 pi over 6, and how we get the reference angle and how we get the sine and the cosine without memorizing anything. We also did angles like the 225, which is the 5 pi divided by 4, and we also did the reference angle, drawing this perpendicular from the tip of the vector to the x-axis in the negative direction here, because we are in quadrant 3, and we said location, location, location. We went further and we gave angles that are not within the 30, 60, or within the 45, 45 isosceles, or the 1, 1 square root of 2. We gave the example of, I believe we gave this one, the 15 and the 75, and we said because of the magical TSC hexagon that helps us minimize the memorization, we go from sine to cosine, and in this situation we go sine of 15 equal cosine of 90, or pi over 2 minus 15, which is what? Which is 75. So sine of 15 equal cosine of 75. So if you know either or, you're good. And then we went even a step further and we said there is no distributive property here. Kids, especially students in grade 8 and 9, when they start learning about this ratio, the sine and the cosine, some of them make the mistake, because it's not really mentioned very well to them, of doing this. We said 45 plus 35. So if you have something like that, that adds up to what? 80 degrees. And you want to split it because, oh, I know 45. So I can go sine of 45 plus. Never. This is not something, this doesn't have a distributive property, because this in itself is a comparison, is a ratio. So you cannot distribute it like that. Okay? You're not distributing, a multiplication of a value. And we said this has a special law that we're going to learn later. And that has to do with the sine and the cosine being partners, lobsters, lover, whatever you call them, and they come together as, sine and cosine, and this cosine keeps the cosine with it. It's greedier. We'll talk about that when we get to it. We'll derive it, we'll explain it. But we said there is nothing called distributive property. We went a step further. We reminded you, and I reminded you of, and you reminded yourself, because math is all about putting all these pieces together, of what's the area of a triangle? It's half the height times the base. And then we drew a triangle that is just like an oblique triangle, no right angles, and we said, if I consider the small, and usually we said in most books, the angles are referred to as capital letters and the sides as, small letters. So across from A, there must be small side A, and across from angle C, there should be small side C. And we said if I want to find the area of this triangle, oblique triangle, all I need to do is just follow the rule, half of height times base. If I consider A, I can take any side and make it the base, depending on what you have in the math word problem. And if in the math word problem, if it's easier for you to take B as the base, then by all means, you take B as the base. So if you take A as the base and you draw the perpendicular to A, you come here and you say, in this right triangle now, I can find these component of a rotating vector. Remember that very well. So the sine of C equals H, the opposite side that I just drew, divided by the hypotenuse, which is B. So I go back to my original and the one that I know very well, A equals half height times base. Half, what's the base? It's A. And what's the height? It's sine C times B. Okay, so now I have area equal half AB times sine C, or the angle between them. So if you choose B as your base, you get half of BC times the angle between them. What's the angle between them? It's the other angle, A. And if you go half AC, it's the angle B, sine of B. So again, you are not memorizing anything here. You're just going by what you learned as half of height times base. And we're following through with that. Now, and after that, we went into something a little bit more detailed that we're gonna explain its ambiguity in this particular lesson. We said there are two laws. You take all these laws and some of the identities in grade 8 and sometimes 9, and then there's a gap, and then you come back grade 11, grade 12, and you take something called the law of sines and the law of cosines. And when we get to that, when we finish with everything, with the introduction, with the functions, for those of you who are going to continue with me and study with me the functions and the inverse function and how do we get the angles, at the end, we're going to get to the laws of sines and the law of cosines. Basically, the law of sine is easier to fathom or look at. In any oblique triangle, you take the elements of one entity, sine of A divided by, meaning this ratio of the angle A that is formed by the angle A, because remember the sine of A, again, it's not an angle, it's the ratio of that horizontal, a vertical component, and you divide that by the actual total force or the total vector or the hypotenuse, okay? And divide that by the side that is across from that angle, side A, equals sine B divided by small b side B equals sine C divided by C. And we said that if you know two sides and then you know an angle that is within one of the easy special triangle, the 30, 60, 90, or the 45, 45, 90, then you're all set. Everything, is dandy. You just, let's say one of the angles like this. I believe we gave the example of something obtuse like this, and we said this is 125 and we want to find out the sine of 125, okay? And they gave you across from it, it's 10. On this side there was a 6.1, and we know that this is 30. Of course, if you know this is 30, this is 25, because even if it's obtuse, the sum of the angle is 180. 125 plus 25 plus 30 is 180. But the point is, you know the sine of 30 from the special triangle. Sine of 30 is your half. This is one of the easiest one. So in this situation, I can come and say sine of A divided by 10 equal sine of B, which is a half, divided by your B, 6.1, and you can get your sine of A. And we said it's something around 0.89, I believe. 0.819. Okay. And then we said there is another law. Right now, we don't want to memorize them, because later on we will derive them and explain, and we will construct geometrically how we got to these two laws. We said there is another law called the law of cosine, and it works perfect when you know the three sides. And you go, we said, and here is the threshold that we're gonna, dig through and go into this, the nitty-gritty of this specific lesson, or this specific video where I'm gonna teach you why we start with the largest angle. Okay, we said, I gave you, I believe, the same example, making A the largest one, and then B we put it at 6.1, and C 510, 512, 512. And we said the law of cosine, when you know three sides, inside that law it goes like this. One of the sides squared equal the other one squared plus the third one squared minus those two and the cosine of the angle itself. And we said we need to start with the largest one. And now we have to explain why we have to start with the largest one and whether we should use this one or the sine. And we're going to go ahead and make the mistakes and show you why you should always start with this one. It's better to use this one, not the sine, because the law of sines has a lot of ambiguity. Unless they tell you use it in a standardized testing, then you use it. Otherwise, it's always preferable, and we're going to see why, to start with this one. Okay, this is just common sense. You don't need to memorize it. If you want to know the law of cosine starting with b squared, it's going to equal a squared plus c squared minus 2ac cosine of b. Okay, and b is the angle between a and c again. So it's the angle between them. There is nothing difficult, even if you memorize it, it's nothing difficult. And we went ahead, I believe we did it. We said the cosine A, we did the math, we took the cosine A to the other side, and A being the largest here, I made it the largest. Now we're going to take it and try to use it with the angle that is not the largest. And we're going to see how there will be a lot of confusion and ambiguity. And I will explain why. Okay, and we believe, let me see here, what do we have? What did we get to? We don't want to repeat that. Oh, something like 0.59, and we said sine square of any amount of rotation, which is the angle, plus cosine square equal 1. So sine square equal 1 of this A now equal 1 minus cosine square. So 1 minus, I believe it was minus 0.59. So minus 0.59 squared, and that will put us at 0.65, and then the square root of, because this is squared here, the square root of this 0.65 gives you something approximately 0.81, which is very similar to the one that we found with when we used the law of, right here, sine, 0.819. Okay, now we're going to use the same, and we're gonna explain why we should always start with the law of cosine. We're gonna make the mistakes and why it's preferred always to start with the law of cosine and use it instead of the law of sine. Now, let's imagine, first of all, let's review that there is the same way I said there is a restriction to draw. For example, we gave that in the previous lesson when we defined the conic section. To draw any line as a tangent to an ellipse, there are two big restrictions. And then in order to draw a triangle from, your middle school, something very simple, what needs to happen? Two of the angles must be less than 180. If you have two angles, angle A, let's say this is angle A, plus angle B, equal or larger than 180, then there is no solution. There is no triangle, just common sense, okay? And we gave the example, if we have a very tiny angle of 2 degrees that goes like this, you're going to have on this side 89 and 89 making 178 degrees, and then you have your 2 degrees up there to make the 180, okay? And we said then, if you know the three sides, it's easier to go with the cosine. And then if you know, let's say, your side squared, c squared equal a squared plus b squared minus 2ab cosine of c, right? Even you can go ahead and find the c if you're looking for the side also this way, and if you know the angle. Okay, so you can just go a squared, square root of this whole thing, okay? And if you want the angle, you just go cosine C equal the same way we did with the cosine A. Now, if, we know two sides, okay? Remember, we used that with the law of sines. If we know two sides, and we know the angle that is not between them, some of you have studied that ambiguity in middle school, in grade 7 or 8 or 9, beginning of high school. So if you know, and it's called the famous, I'm not going to pronounce it, the famous ASS. ASS is basically what? Side, two sides, and an angle that is not between them. So first of all, we're going to study if we have an acute angle. So if you have one of the angle, let's call it angle A, is less than 90 degrees. What solution do we get? So if I have this is my A angle, this is A vertex, A angle, and it's acute, okay? And so the small side, side A is across from it. So this is side A. But wait a second. What about these two sides? What do I know about them? Now, if I call this one B, because this is my angle B, it's going to be here, and this is going to be A. Now, if B is smaller than A, or this side A across from that angle that I'm interested in is larger than B, then yeah, by all means, I can finish the triangle, constructing geometrically, and I get one triangle. However, what if B as a side, as a length, is equal to A? I will still get my isosceles triangle, right? So I go here, this is my A, this is my B, this is my, and I draw and I construct A and I get an isosceles triangle. And in this situation, angle A is gonna equal to angle B. Very simple, very easy. We all agree on this. So we're studying the situation where this angle that I'm, looking at is what? Is acute. Now, what if this angle is not acute? And what if this angle is obtuse? But first of all, let's stay with acute again. What if this angle is acute? And again, and this is A, and this is B, and I'm studying angle A, okay? And in this situation, what do I have? I have B larger than A, or this side A across from this angle that I'm studying being smaller than B, okay? So what happened in this situation? In this situation, there is no solution. Oh, okay. So when I use that law of sine, actually there is a lot of ambiguity, because many students use the law of sine when you have this famous ASS, two sides and an angle not between them. Unless you're told to use it, you have to use it. If you're not told to use the law of sines, you have to use the law of cosine. We'll get to that in a second as to why. However, what if that angle A now is more than or equal to 90 degrees? There is only one solution in this situation when B, this B here, is what? Is less than A. Look at that. So if B is small and I have an obtuse angle like this, let's say the 125, this is my A. If B is smaller than A, by all means you have one solution. However, look at that very perfectly. If this B, you have the obtuse angle, this is your A, the one we're considering, and this is the small a, the side across from it. If the B is larger than A, no solution. Okay? So again, there is a lot of ambiguity, when you use the sine, the law of sines. That's why it's better to go with the law of cosine and to start with the largest angle. Why do we start with the largest angle? We're gonna explain why in a second. We're gonna make the mistakes that, I made those mistakes when I was in middle school and first year of high school. I remember, or maybe second year of high school, we took that law of sine and law of cosines. So let's go back to our first example, and let's keep A at 10 centimeters. Well, let's make B now bigger. Let's make B 20. And let's make C 15. So I know three sides, it's very easy now. I understand this law of cosine. Let me go ahead and use it. Cosine of A, and you don't pay attention that A here is not the largest side, so you go cosine of A equal, you flip it to the other side, equal B squared plus C squared minus A squared divided by 2BC. And if we put them together, B squared is 400, C squared 225, minus 100, A squared. Divided by 2BC, 20 times 15 times 2, that's 600. And then what do we get? We get cosine. Okay, now we need to talk about something before we dig deeper here. Now, if you know the cosine, how do you get the angle? We're going to get to that very, very soon. You get the angle with your inverse function, meaning the same way when we studied, let's say, log, for those of you who know the logarithm, base 2 and what? Base 2 of 8 is 3. How many times do that's how I think about it. This is a very easy way to think about it. How many times do I multiply 2 by itself to get to 8 or to get to 2 to the power 3? 3 times. Same way here. I think of the easiest angle. What is the ratio that give me an angle of 30 degrees? It's 0.5. It's 1 divided by 2 because the sine of 30 is a half. So that's for those who don't know it yet, we're going to get to the arcsine and the arctangent and arccosine being the inverse function, you know, over the y equal x identity. But for now, let's just stick to something very simple. What's the sine of 30? The sine is a ratio, remember, of 1 divided by 2. That's the easiest one, 0.5, a half, okay? So if I'm going to go and spit out the same way I do with the log to get that, if I'm going to spit out the angle instead of the ratio, so I go of sine, I write it like this in math, minus 1 of the half equal 30 degrees. That means it's the inverse. The function that spits out the inverse that we started with. We started with 30 degrees to get this ratio of a half. If we start with the ratio of the half, we spit back the 30 degrees. So we call that arcsine, or they write it in some books, sine of minus 1. I like to write it arcsine. When we get to the arcsine, the inverse, I'll tell you why. It's easier actually to think of it as arcsine of a half is your 30 degrees. Okay, and same here. So if I get the cosine is going to equal to 0.857 here, the answer, I think. But I want to find the arccosine, or cosine minus 1 of 0.875, or arccosine of this 0.875. Now here you need your scientific calculator. You will be allowed a calculator. And you will spit out and you will get an answer in radian. I believe it's something like that, 0.5. Let me see here. Yep, it's 0.505 radian. Radian. Now, how do you, get that? Like I said, you need to use your scientific calculator here. You will be allowed a calculator. Now, in some books, oh, perfect, you know. Now I know that angle A equal 0.505 radian, and then you convert it to degrees. How do you convert to degrees? We said we don't memorize anything. We do like this, and we put this here now, 0.505, and we get it in degrees, and I have my angle A as 28.96 degrees. So all I need to do now, just go ahead and find my, one of the other angles. So I can use this law. The teacher, showed me how to use this. This is very easy. You just stack them up like this. And I know my A, which is 10. And I can find sine of B. And I know B is 20. So I can get rid of the 10 here. And you go ahead and you find out that your B, or sine of B, equal what? 0.968, which is like, you'll be like very happy with that because it's less than 1. Remember, it's a ratio. When you calculate it, it's a ratio, and it should be between -1 and +1 because the sine function and the cosine function are between -1 and +1. So it'll be like, perfect, I'm on the right track. So all I need to do is just go and inverse it in this scientific calculator. When I learned that, arcsine of B, or arcsine of this 0.968, and I get a radian of 1.317 radian, which is, I convert it to degrees and I get 75.47 degrees. And it will be like, perfect. And now I can just go ahead and do 180. I know A is 28.96 and B is 75.47 degree and C equal 180, and you do the math and you get angle C equals 75.57 and be like, done. But look at it, basically. C is across from C, there is a side, there is 15. Across from B, there is a side, there is 20. So which one should be larger? B should be larger. Wait a second. So there's something wrong that we did. Again, the ambiguity here comes from which side is smaller. And remember when we studied that, we just said, you have to, look at the angle, first of all, make sure is it acute or is it obtuse? And this adjacent side to the angle, is it larger or smaller than this other side? So I always like to use A because I can put A here and B on this side. So, and I would say if B is what? Smaller than A, if B is smaller than A, meaning A is larger than B, then I can go ahead and construct the rest of the triangle, even in an obtuse situation like this. If A is larger, you can finish it. However, I'm sorry, this is the adjacent one. If B is larger than A, like in this situation, A is very small, I cannot construct it. So basically, we need to look, we cannot just go ahead and use the law of sines. Unless they tested it, they gave you a math problem or a math word problem, and they tell you, use the law of sines to calculate an angle or to calculate a side. Otherwise, we need to use the law of cosine. But why do we have to start with the largest angle? We just said it, and we're going to make another mistake to show you again why it's better to start with the largest angle. Okay? Let's make the other mistake. Let's say, here. Should we stick? Yeah, let's do the same numbers. So we have A as 10, and we have B as 20, and C as 15, to make it easy with the squaring. And let's say you start with cosine of B this time. Cosine of B, the largest one. Because if you're going to start with the cosine of C, let me see, if you start with the cosine of C, you're going to make the same mistake, but I also wanted to make another mistake for you. Yeah, that's what I wanted to do. I'm sorry. First, let's start with, studying without the cosine of, if you're not convinced that this stacking and the sine, let's use the law of sine again. Let's say sine of A divided by A equal sine of C divided by C. Because this is very easy. I already found the A, A is 28.96 degrees. I can find the sine of that. I have my scientific calculator. So you plug in sine of 28.96 degrees, because I had one student one time, they made that mistake. They was like, this is easy. Let me do it. I have the scientific calculator. I know how to use it now. Perfect. Sine of 28.96 degrees gives them 0.484. Perfect. You said it should be under 1, and then I put my tan, and I can find my sine C, this last angle, and then they go ahead and they find that sine C, what do I have here? Sine C equals 0.726. So again, they use the scientific calculator to calculate the arc sine of 0.76, the angle, to switch it to over the y equal x identity to find the inverse. And they find an angle in radian, they convert it to degree, they get that C equal 46.55. But wait a second, we just did the same number with the law of cosine and sine mixed together, and we got that C is 75 degrees. And if you're gonna add them up now, if you add up this 28.96 degrees plus the 46, the one that you found, the C, 0.55, plus the B, which we found in the beginning, 75.47, what do you get? I believe 150. Yeah, you get 150.98. Is this really a triangle? It's not a triangle. It's less than 180 because you didn't look at the sides. So again, the key before you do it, first of all, it's better to use the law of cosine. That's the first rule. You start with the law of cosine and with the largest angle. And you need to keep this one in mind. I'm studying this angle, but I'm going to make sure that the side adjacent to it is that side larger or smaller than the side that is, associated with this angle. I'm studying this angle, okay? Considering this is the largest angle, okay? And that's A. And I'm going to study the side adjacent to it because I want to construct geometrically. Geometrically, even if you're using a compass, I'm going to see now, is this side B smaller than the A, the one associated with this largest angle, or is it larger? Okay? If it's larger, then there is no solution. If it's smaller, then you can go ahead and construct geometrically. Okay, so now we can go ahead with our peace of mind and say that the restrictions is first to calculate the angle using the law of cosine, unless you're told to use the law of sines, and to always calculate the largest angle opposite to the largest side first. And when you use the law of sines, never use it to calculate the largest angle because you saw the ambiguity. And in general, for angles, the law of cosine give you a better answer, unless you're told to use the law of sines. So if we go back to our example, because we don't want to give many, let's stick with the same numbers. A equal 10, B equal 20, and C equal 15. If we take the largest angle this time, we take the cosine of B. Cosine of B is what? Is B squared, A squared plus C squared, A squared 100, plus C squared, which is 225, minus B squared, which is 400, divided by 2AC. 2A, 2 times 10 times 15, so that's 300. So 100 plus 225 minus 400, that's minus 75, divided by 300. Excuse my 300. Okay, so that's minus a quarter, minus 1/4, minus 0.25. And we're good. It's something that makes sense because it's between -1 and +1. Now you go ahead and you get your scientific calculator and you do arc cosine of this minus 0.25, and you're going to get your answer in radians, and you get 1.82 radian. And then you do 180 degrees, stack it up with a radian, which is pi, which is 3.141592, and this is pi, and this is my 1.82, and I find out the degrees. And I get a degree that is almost 104, let me see here, 0.28, 104.28. So makes sense because this is the largest one. Okay, so we already know cosine of A. We did it. It's 28.96 degrees. Okay, so now all we need to do is just go ahead for C and do 180 degrees minus the largest angle now, B, 100 plus 28.96. And what do we get here? We need just a regular calculator, and we get an answer of 46.76. 46.76. Now it makes sense. The largest angle is B. The largest side is B. The one in the middle is C. The angle in the middle is C. And A is the smallest one. Now, if you try this using the law of cosine, you should get the same answer. What do I mean? That's what I wanted to do earlier. And then if you try it with cosine of C equal A squared plus B squared minus C squared divided by 2AB. Okay? And then A is 100 squared, B 400, B squared 400 minus C squared 225. 2AB, that's 2 times 10 times 20, 400. So I get 275 divided by 400. So this is, let's see here again, regular calculator, 0.6875. 0.6875. Okay. So now I didn't use 180 minus the other two angle. I used the law of cosine to just assure myself that I'm using the right formulas. This is the right approach. I started with the law of cosines with the largest angle. That's the restrictions. I'm following the restriction. I get to a cosine C equals 0.6875. If you take the arc cosine, I'm sorry, of 0.6875 and you do it in your calculator, you're gonna get the radian, and then you will get a 46.6 degrees, which is all of the difference is in the 10th due to the rounding errors, of course. Okay, so that's in a nutshell what we're gonna be studying once we finish sketching and doing all the functions. Y equals sine of x, y equals sine of x plus 3, y equal cosine of x, y equal tangent theta, cotangent, cosecant, their inverses. We're going to study the frequency, how to draw the amplitude and the frequency and all that good stuff. Once we're done with that, we're going to switch back to the law of sines and law of cosines. And the law, this is in a nutshell what, the restriction, the first restriction that you need to know when you use your law of sine and the law of cosine. First, you always calculate using the law of cosine and always calculate the largest angle opposite to the largest side first. If you are to use the law of sines, never use it to calculate the largest angle, and don't use it unless you're told use the law of sines, because they probably tested it. They want you to just stack them up in a equivalent fraction. Sine of A divided by side A equals sine of B divided by side B. So in general, for angles, the law of cosines give you a better answer. Okay, now we still have time. We're gonna go into something, actually it's easy. They start you with that in grade 8 and 9. It's called the angles of elevations and depression. And the angles of elevations and depression, they're actually very in line with your opposite side divided by hypotenuse, or adjacent side divided by hypotenuse, depending on where you are. And they usually give you the example of the lighthouse, because with that you can go this way. So basically the angle of elevation is when you're using your eyes and you're not looking straight, you're looking up. And the angle of depression, let's say you're standing at the top of this lighthouse and you're looking down at a boat. So it's the angle that is going to be formed when you look down at the boat and the straight horizontal x-axis. So let's do it here with easy numbers. And again, you're going to excuse my, I don't really sketch and draw very well. Let's imagine this is the lighthouse, okay? And there is a person here on top watching the boats. And this is in many books, it's the same example. They give you the lighthouse example because it's very easy to conceptualize and fathom. And they tell you, he's looking down at a boat, and he could be looking up. We're going to do the looking up very soon after this. Looking up at a bird or at something in the sky, but he's looking down at the boats, of course. And let's say there is a boat here. Okay. And he's looking down, let's make it easy, with an angle that is, let's say 30 degrees. Okay, so this one is what this one is, your 60 degrees. Okay, complementary is 60 degrees. And in some situation, they give you this, they don't, like the horizontal, they tell you, let's make it X. And let's make this 40 or 50, 40. Let's make it 40 feet. Okay. And, you have many options here. Those are very easy to deal with. You can, if this is the angle of depression, right? The angle of depression is 30 degrees. He's looking down at the boat with an angle of 30 degrees. So the other angle to finish this right triangle is your 60 degree angle.
And with the 30 and the 60, I gave you the easy example because we can find out the sine and the cosine without going to use our scientific calculator. You can do tangent of 60 equals what? Equals opposite. This is the x, right? This is 60 right here. Opposite divided by adjacent without, even if you don't know this hypotenuse. Because the tangent doesn't need the hypotenuse, doesn't need the total force, doesn't need that rotating vector. That's the beauty of the tangent. It goes with the broken elements of the vector, of the rotating vector. So you don't need the hypotenuse, you don't need the total force. If you are in a physics problem that has a rotating vector or a resulting vector, you don't really need it when you use the tangent. You go x divided by the adjacent, which is 40. And what's the tangent of 60? The tangent of 60 is if you remember your special triangle, this is a special triangle right here. I'm not memorizing anything. It's half of the equilateral triangle. This is my 60, right? And this is probably my 30. And this is the 90 degrees. And we said adjacent to that 60 is the 1, hypotenuse is 2. And this is like this. So what is the tangent of 60? The tangent of 60 is opposite, square root of 3, divided by adjacent, 1. So it's square root of 3. So I have square root of 3 equal x divided by 40. So if I am to find the distance between the lighthouse and the boat, I just do x equal 40 times square root of 3. Very simple. So using the tangent, again, keep that in mind. You can bypass the hypotenuse, bypass that total vector, that resulting force, or whatever it is, whatever hypotenuse or h is. You can use it in a different way. If you are, let's say, if you want to use the 30 degrees, not the 60, not the complementary. Let's give the same example. And let's go like this. And let's give the same example. You can go x. Let's do this as 40 feet. And he's looking down at the boat, again, with an angle of depression of 30 degrees. You can do the tangent of the 30 degrees itself. You don't need to find the complementary. If you know you can do tangent of 30 degrees equals what? Opposite, which is 40, because opposite of 30 is this one, is your 40, is the lighthouse itself, or the reflection of the lighthouse over there, divided by your x. What's the tangent of 30 degrees? Again, I don't memorize any of that stuff. I go back to my special triangle. This is my 60, this is my 30, this is my 1, this is my 2 hypotenuse, this is my square root of 3. This is my 30 now. It equals opposite, 1, divided by adjacent. That's the tangent. I don't use the hypotenuse. So 1 divided by square root of 3, or if I do times square root of 3, I get square root of 3 divided by 3. So in this situation, what do we get? We get square root of 3 divided by 3 equal 40 divided by x. Okay? So, and you can find your x this way. Now, we're going to wrap up this video with a very, very real-life example that happened actually maybe more than 20, maybe around I believe 30 and more years ago, and it happened here in the States, I believe in Manhattan or in the Bronx, in New York City. And there was a narcotic bust into one, and then they stormed the narcotics, they stormed the authorities, they stormed an apartment building, and they busted, unfortunately, a large amount of drugs and stuff like that. But the apartment they busted, they had like 2 young kids. Unfortunately, was like maybe 20 or 21 years old, and they had a baby with them. And the female, she had a 3-month-old baby, and she ran when she was, under the influence of drugs. She ran to the balcony when they stormed the apartment. And according to her, because she was afraid, according to her lawyer, the baby fell off I don't know if it was the 12th floor or something, or the 8th floor or something like that. But there was an eyewitness he said, it was an older man, he said he saw her literally and intentionally throw the baby. So of course the big team of forensic science, the FBI was involved. I believe it was, in one of the TV series. They brought in, forensic scientists. They calculate the angles. They know they have, of course, their algorithm and everything. And they wanted to check how accurate a person can see from a certain distance. So they brought in also all kind of renowned doctors in ophthalmoscopy and optometry and all that good stuff. So I'm going to make it very simple. I shrank the numbers just to make it easier for you. I scaled the numbers down. So let's say this apartment building, is 600 feet. And this guy, this eyewitness, is viewing this building with an angle of elevation at the top. We can mix, by the way. This is why I want to give you this example. You can mix the angle of elevation. You could be standing in front of your window looking at an apartment building or a high-rise across from you. You can look up and you can look down, of course. So there is an angle of elevation and there is an angle of depression. So let's say he was looking with an angle of elevation to the top that is 30 degrees. Let's make it easy with the 30 degrees. So in this situation, the angle of depression to make the 90 degrees is 50 degrees. How far away is the apartment building? Can he really see it depending on his age and all that good stuff? We're not forensic scientists. We just want to find the numbers here. Okay? So let's say this is the eyewitness. He was in his hotel room or apartment building here. Across from him, we don't know the distance, there was this apartment building. Okay? We don't even know which altitude, which floor he was in. We just want to find the distance between him and this apartment building. The rest is not for us. This for, forensic scientists and, doctors and scientists to figure out whether he was able really to see that. But I'm just giving you a hint that these problems, they mix very well with real life. This is not something that you just study in school just to, it's, opposite side divided by adjacent side. That's my tangent, okay, I got it, let's move on to something else. Those are the basics of any higher level of education. These little things that you take in middle and high school, okay? So let's say he's looking, this is his eye, okay? He's looking here, and the angle of elevation is 30 degrees, and to make the angle of depression, this is 50. He's looking at this from his window. This is 30 degrees, this is 50 degrees, okay? And the whole thing, this whole apartment, I made it, I scaled it down. I made it 600 feet, okay? So from here to here, it's 600 feet. So if he's looking with a 30 degree up, okay, the whole thing is 600. From here to here, it's 600, okay? So let's call this y, and let's call this, what do we call this? If you have 600 y and you're dividing, it's basically 600 minus y. So this thing here, let's make it 600 minus y. So if I am to use the tangent like I told you, because they're easier, you don't need to know the hypotenuse. We don't know this one here. So let's use the tangent like we said. I apologize. Tangent of 30, which is square root of 3 divided by 3, we just found out in this special triangle. Tangent of 30 equal what? Y divided, opposite divided by, let's call this x, since it's the horizontal. Okay? So far so good, right? Now what's the tangent of 50? The tangent of 50 is the opposite, which is 600 minus y divided by x. Very simple, right? So let's write it here. Let's say tangent of 50, which I don't know. I know the tangent of 30, okay, equal 600 opposite minus y divided by x. So if I am to go like this, I can, go x, or I can do like this. I can do 600 minus y equal x times tangent of 50 degrees, right? Now, 600 is what in this situation? The whole building. So if I am to go 600 minus y, which is the one on, this right here, 600 minus y gives me this altitude. If I want to add the y to it, I get the whole 600, right? And I already know that 600 minus y equal x times tangent 50 plus y. What's y? I just found out that y equal x times tangent 30, right? So now I have this whole thing equal x times tangent 50, so x times inside tangent 50 plus tangent 30. I know one of them, right? That makes it easier for me. All I need to do is just find out what tangent 50 is. So if I go back here, I have x times, I open the parentheses or the brackets, tangent 30 plus tangent 50 degrees. I know one of them, which is the tangent 30, which is square root of 3 divided by 3, which is around 0.57. You will get to know that if you keep practicing. So this is 0.57, and you can go to your scientific calculator and you can get this as 1.19 as a ratio, the tangent of 50. Okay, so now you have x times what's 119 plus 0.57 is 1.76. So you have x times 1.76 equal 600, the whole building. Remember? Because we said this whole thing equals 600 minus y plus y equal the whole altitude. Y plus 600 minus y. So now we know everything, so we can find x. So x equal 600 divided by 1.76. And x is the what? X is the distance between this eyewitness, his eye, and this apartment complex across that he claimed he saw that the young girl threw the baby intentionally from. Of course, the numbers are scaled down. They're not like this. They're was, I believe, not a skyscraper, but a very high rise with like 30 floors. So the answer would be 176. The answer would be 340.9 feet, around 341 feet. So now you did your job. You found the x, or the distance between his apartment or his window or his, where he's standing, and that high-rise or apartment building across from him where he claims he saw something happen. It is up to the police, the investigators, the FBI, the forensic scientist, and the doctor to determine if a person in his age is able to, really see from that distance, accurately, and, can tell what really happens intentionally or unintentionally. Okay, so I gave you this example just to link to the back of your mind that this is fun. This is not something that, okay, just a lighthouse, let me find the angle for the teacher or to pass the test. This is at the base of any higher education that you're going to go to. If you don't know your basics, you're not going to, be passionate about what you study in the future. Okay, I'm going to wrap up with this. In the next lesson, we are going to talk more about the inverse function, the arc sine, the arc cosine. How do we get that? And why is the sine and cosine related to the odd and even functions? When we think sine and cosine, many of the identities are related to them being one of them odd, one of them even, and not to the reflection over the x-axis and the y-axis. And we're going to give examples to why, they're not really related to the reflection of over the x-axis and the y-axis because of the location, because of the quadrant. In some quadrants, the sine is positive, and in the same quadrant, the cosine is negative. So that's why when we think sine of cosine, we're going to think odd and even. What I meant when we talk about sine of minus theta or minus x being minus sine of x, or cosine of minus theta being cosine of theta, we're relating to the odd and even behavior of a function. And we're not talking about the reflection or the transformation of the function. We're going to talk about all that in the next lesson over the y-axis and the x-axis. And simply because in one quadrant you can have, like in quadrant 4, you can have the cosine being positive and the sine being negative. So that, demolish this idea of relating the sine and the cosine to only the reflection over the x-axis or the y-axis. We will talk in details about this in the next video, but this is what we're going to talk about in the next lesson in this very lengthy introduction, because again, sine and cosine are not just opposite side divided by the hypotenuse or adjacent divided by the hypotenuse. They go deep into your basic knowledge of math. They get you ready for any scientific degree or major you're gonna go to in college. Okay. With that, I will wrap it up, and I will see you in the next lesson or video.